Hi everyone. Welcome to my session, Achieving End-to-End Phishing Resistance with Entra ID Passkeys and Platform SSO, which I know is a mouthful. My name is Michael Epping. I'm a product manager from the Microsoft Entra product group, so from the identity side at Microsoft. I work specifically on a team called the Customer Experience team. Basically what we do is we help customers with their deployments, get feedback from customers, sit with our engineers and our feature PMs who actually go build these features, help them understand what can we do to make the features better, what are customers asking for, where are the rough edges, the problems that they're running into. So with that, I'm going to jump into the agenda. So there's a couple things I'm going to cover here today. Let me see if I can get that mouse pointer out of there. All right. A couple things I'm going to cover here today. So I'm going to talk about phishing-resistant authentication and what we mean by this. And I'll give some good reasons why I want to talk about this. Then we'll talk about an overall deployment approach. Like if you're using Entra as your IDP, or really if you're using any IDP, like I can speak most specifically about Entra, but we do have customers who use Microsoft services who are using other IDPs, whether they're on-prem or cloud-based. You can do many of these same things with those other IDPs. Of course, we'd like it to be Entra, but it doesn't have to be. And then we'll talk about some specifics for Apple deployments. So what to do with your iOS devices, what to do with your Mac devices, what are we recommending that customers do in their environments, as well as what does Microsoft do for our own employees, because we like to share what we do, because a lot of times customers can learn from that. Talk a little bit about what's coming next, and then I'll leave you with a couple action items that I want you to go do. And then I'd like to leave plenty of time for Q&A, at least 15 minutes. So I know some folks may have questions. I will try to make sure we get to all of them. All right, so I'm going to start with the overview, but actually before I jump into this, there's a couple questions I want to ask, and just do raise of hands to get responses here. So how many people in the audience would classify themselves as a device admin? Okay, most of the room. Anybody from, say, like a security team rather than being a device admin? Okay, got at least one, two. Anybody from the identity team at their organization? Okay, got at least two. So this is about what I expected. Most of the room are the device admins. So the reason I want to talk about phishing-resistant authentication is because this is a big thing that Microsoft and other vendors in the industry has been talking to your identity and your security teams about a lot over the last couple of years. And so I want to try to give you the perspective of why are your identity teams coming to you and talking about stuff like phishing-resistant auth, secure enclave key-based authentication. Like what is the perspective of identity and security that is trickling down to you, the device admin, and like why do these things matter? Who here has already deployed Platform SSO in their environment? Okay, a couple hands. How many of you who have deployed it are using password sync? Okay, anybody using secure enclave key? Anybody, a little bit of both, all right, all right. Anybody using the smart card option? Okay, I know from telemetry there's like 20 of you worldwide, so I'm not surprised nobody raised their hand. All right, how many people are not convinced that they should do secure enclave key? Okay, not many hands, that's good. It means people are at least open to the idea that we need to move in this direction. So to start with talking about phishing-resistant auth, from an identity and a security perspective, the user's password does not matter. It is something that if an attacker wants it, wants to compromise it, wants to exploit it, they are going to. So ultimately, we need to get rid of passwords. They are not really all that defensible a mechanism anymore. I don't really care what your password rotation policies are. You make users change them every 90 days. I don't really care how complex you make them. In fact, if you make them overly complex, your users are going to write them down and stick them on Post-it notes. There's all these negative things about passwords that we really cannot solve. Like they are just inherently a bad credential. So users can do all sorts of really nasty things like reuse them. So if an attacker gets it in one system, they can use it in another one. Like, for example, I was just talking with a gentleman up front. We have users who may have one password in Entra, and then in his environment, there's another application that users use that doesn't use Entra for auth. I would be willing to guess that there are users who are using those passwords for both systems, the same password. So if you manage to compromise it in that app, you could then take it and replay it against Entra. Even worse is a particularly determined attacker will be able to get your user to fork it over, or at least some percentage of your users. And these attacks are getting really, really sophisticated. An attacker typically will start this type of attack by sending a particularly tricky looking email. Maybe it gets past your email filters, because email filters will try to slap down these phishing messages, but they're never going to get 100% of them. Or the attacker is going to call the user and pretend to be the help desk. They're going to find all these ways to get in the user's face and basically ask them, what are your credentials? Can you validate yourself to me? I look legitimate. You should tell me what that password is so that I can make sure you are who you say you are. And the user, some percentage of your users will always fork it over. I don't really care how much phishing training you do with the end users. There's always going to be like 40, 60, 80% of your users who will immediately forget all that training that you did for them. And then ultimately, once that attacker has that password, they can now use it all over the place again. So they can use it with your IDP like Entra. If you have multiple authentication systems, like you have an on-prem Active Directory and an Entra and other applications, the attacker can probably use it in all those places and begin pivoting throughout your environment. So what we really need to do is try to solve the problem for credentials that are both easy to use and secure. So passwords are super easy to use. There's a reason that they are still pretty ubiquitous, even though there have been alternative options available for decades at this point. They're super easy to use, especially now if you have like a password manager. It's like really, really easy to create passwords and manage them. Most users won't do that, but some will. But ultimately, they're not very secure. Even if you do have good practices like a password manager, they can still be stolen, they can still be intercepted. If an attacker is listening on the network, they can intercept it without any knowledge on your part. So what we've done over the years is we've layered in complexity. And this really starts with complex passwords, making it harder and harder and harder to guess the password. Making your passwords more complex does nothing if the user faces a phishing attack, or there's some sort of man-in-the-middle attack where the attacker will intercept it on the network, sniffing on the wire. All you've done is made the user's device a little bit trickier and made guessing trickier. Then we layered in multi-factor authentication, so stuff like OTP codes, SMS, push notifications, email codes in some case, which I really don't like seeing in the enterprise, but do get used. So we're really looking for that thing that is easy to use and secure. And so this is the direction as an industry that we need to go in. So this is the direction that like Microsoft and other vendors are telling your identity teams and your security teams, like this is where the whole industry is going, and you need to go along for the ride. So I want to talk a little bit about what actually goes into this box and how this applies to Mac users and iOS users. So ultimately, the way that the industry wants to solve this is using FIDO authentication. So I want to talk a little bit about FIDO. FIDO stands for Fast Identity Online. So if you're not familiar with that, you can look it up. But the modern protocol for FIDO is what's called FIDO2, also sometimes known as Passkeys. Passkeys being kind of the more friendly marketing term. But regardless of what you call it, it kind of all works under the covers in a very similar way. So we have something like an authenticator. So historically, this has been like a USB key, like a YubiKey. It can be an app on a phone. It can be iCloud Keychain, which can hold passkeys now. It can be Google Password Manager. There's all sorts of different options here. But ultimately, you need something to possess that passkey. When the user needs to authenticate, what they're going to do is instead of sending this weak, interceptable, reusable password over the network to authenticate, they're going to use public key, private key cryptography. If any of you have used smart cards in the past, we're working on the same principles here, just doing it in a little bit more of a modern way with some more modern user experiences. But ultimately, the authenticator possesses a private key that is dedicated to that one specific application. So if we're thinking about Entra, we would want this to be a private key that is only for login.microsoft.com. It works on no other websites. Your iPhone will refuse to present it if you tried to use it on an alternative website. On the Entra side, the only thing we're going to store is a public key that corresponds with that private key. So we don't need to store any sort of secret that can be stolen when it's presented to Entra. We don't need to store anything that if an attacker managed to compromise the storage in Entra, which won't happen, but is within the theoretical realm of possibility. There's nothing really there for them to steal. Public keys are inherently not really valuable. Then, when the end user wants to actually use that private key to prove themselves to the IDP, like Entra, we need to ask for some sort of user verification. And the way we do that is preferably, in most cases, through biometrics, just because it's the most convenient way for the end user. So this might be Face ID, Touch ID. If you're on a Windows device, there's certain other options available. It'll differ by operating system and hardware. But biometrics are a great user-friendly option for users who opt into them. Alternatively, there are options like pins and memorized secrets that are specific to that physical hardware. It's not sent over the network. It's not something that an attacker can exploit if you give it up to them. Like, I have a pin on my iPhone. It does not do you much good if I tell you what that pin is, unless you actually physically steal that iPhone that pin is useful on. And then there's basically a challenge and response with the server. So when the user wants to authenticate to Entra, rather than sending that password over the network where it can be intercepted, stolen, replayed, if it is intercepted, then replayed against other applications and websites, none of that exists with FIDO. Essentially, there's a challenge and a response where Entra or the resource provider will say, I need you to sign something with that private key. The user will do the gesture. That random bit of data that's provided is signed, and then that response is returned. And Entra just validates it with the public key. So if you manage to steal this signed response, it doesn't do you much good. You can't go then use it for other things later. It's just good for this one session. And all Entra has on our side is the public key to validate it with. So this is much superior to password auth if we're trying to make our environments more secure and make our user authentications to resources that are tied to our IDPs more secure. So I showed this slide last year at our talk, but I want to briefly mention how Platform SSO fits into this, and I'll go into some more detail about Platform SSO and how we recommend deploying and all those good things a little bit later in the talk. But just as a kind of recap for folks who may have caught some of the presentations we've done on these topics over the last year or so, Platform SSO is ultimately just a framework Apple provides. And within Platform SSO, there's 3 different options that they offer for authenticating with a directory like Entra. So we do support all 3 of these, and these are the 3 I asked about earlier. One is password. It does what it says on the box. It basically keeps the local password of the Mac in sync with the cloud IDP. This doesn't meaningfully move the bar forward on security because that is still an interceptable password that is being centrally stored in the directory. It's being sent over the network. The user can be tricked into giving it up, and if they do give it up, the attackers can very easily exploit it and then replay it against other applications. But there are valid use cases for using this, like school computer labs is like a very common one I hear about, where you just want the student to sit down at a different computer every day and be able to sign in with their class password. Sure, okay, I can accept that there are some valid use cases. For the enterprise, and especially for machines where we have more of a one-to-one relationship between the user and the device, we really should be angling for one of the other 2 options, though, the ones that meaningfully move the bar forward on security. So one of those is Smart Card. I'm not going to spend too much time talking about that, but if you have questions about it, we can definitely address them. Ultimately, this works very similarly to how Smart Card authentication worked from a user experience perspective prior to Platform SSO. It's just now that Smart Card cert is being validated by the cloud IDP rather than some on-prem endpoint. But the really new thing, and the thing that we really tried to impress upon people they should deploy last year, and the thing I'm going to impress upon people they should probably deploy this year, is Secure Enclave Key. So this option all the way on the right. Under the covers, this uses the same protocols as Windows Hello for Business. So in a lot of organizations that I work with, the device management on the Windows side is very actively or has already deployed Windows Hello for Business as part of their phishing-resistant strategy. Because this is an option that uses that flow I talked about earlier, where instead of sending passwords anywhere, we're doing public key, private key cryptography to authenticate. So this has existed on Windows for like 9-10 years at this point. With Secure Enclave Key, we reuse that same protocol and do that same type of authentication on macOS. The user experience is definitely different than on Windows, like they're different operating systems from different vendors, so naturally they're a little different. But from a security perspective, they give you many of the same guarantees, including phishing resistance. So what I was talking about earlier, like we really want to move in this direction of asymmetric cryptography so that we get this phishing resistant nature to our authentication. The big thing to understand here is that when you choose this option, we don't sync the local password of the Mac. It basically has become the equivalent of the PIN on my iPhone or the PIN on my Windows device, and you may even want to consider managing it as such. I know on the box in every version of the OS that I've seen so far, including Tahoe, it says password, but fundamentally, if we think about it from a security perspective at the organizational level, that is a device-bound memorized secret that we are using to authenticate locally to the hardware, so the hardware can use that private key to go authenticate to services, cloud resources, Entra, other IDPs incredibly securely. So this is really the direction that we'd like to see customers going in, just like we're pushing for Windows Hello for Business on the Windows side, just like we're pushing customers to adopt Passkeys on their mobile devices, which I'll also talk about more in a little bit. And then you can actually use this in passkey flows. So it's available if the user does run into a WebAuthn challenge. You can use this to basically re-authenticate the end user. It's essentially using Touch ID on your Mac to authenticate to Entra to get a fresh set of tokens. But if you have a device that doesn't support Touch ID or an external keyboard or whatever it might be, you can always fall back to that local PIN, which we should be managing like a device-bound PIN and no longer synchronizing to a central directory, therefore defeating the purpose of it being device-bound. So the promise of FIDO2, like what all your identity admins and your security admins, if you have those in your organization, are really thinking about is trying to solve some problems that we see attackers more and more frequently going after, which is attacks that are viable remotely are obviously much easier to do at scale. Like if I can wage an attack without your security team knowing, that's going to be much easier than an attack that requires me to like physically enter your building or sit in your parking lot and get on your guest Wi-Fi. Like those are real scenarios that you may want to worry about. But if I can wage an attack from anywhere on the globe, obviously that's going to be a lot easier. We don't want attacks that can go undetected. So again, there are ways to compromise passwords and traditional forms of MFA that are very, very hard for IT to detect. We don't want durable credentials to leak. So basically, if an attacker manages to compromise the password, how long are they going to be able to use that credential? Even if you have a 90-day password rotation, maybe it's 15 days, 30 days, 45 days that the attacker can use that credential and find other ways to gain persistence. We also don't want attacks that are cheap. Password attacks are super, super, super cheap for attackers to wage. Like it's comically inexpensive for them to do password-based attacks. And then they are also incredibly scalable. Like you can wage a password attack on hundreds of thousands of users in Entra very, very easily. There's lots of tooling out there that attackers leverage to do this. So what we're looking for is a way to deflect these types of attacks where the credential is unguessable, so that's the whole point of the public key, private key. It's undisclosable, and what this means is that the user cannot make a mistake. They cannot accidentally leak that private key. It's bound to the hardware. The user cannot give it up. Even if the user does go to a malicious website, the phone has no mechanism, or the Mac has no mechanism to cough up that private key so that the attacker can have it. They would have to have physical access to the device and probably some very expensive hardware to try to crack the secure enclave, which Apple will pay you a bunch of money if you figure out how to do it. It should be multi-factor. So In our implementation, we always do consider secure enclave key to be multi-factor. So it's a combination of something you have, which is the physical device with that secure enclave key on it, and then either something you know, which is the PIN, or something you are, which is the biometric. Generally, it should be single user. Shared credentials have a lot of security problems that go along with them. We generally don't want to use these types of credentials in shared scenarios. It should be something local, so something that's on the device that they're actively using. Anytime we need to make the user go use a different device to authenticate, their life gets harder. And then it should be uninterceptable and unphishable. So hopefully I've made my point here that we really want to try to get to credentials that are safe from attackers waging these types of attacks that we just cannot train our end users to defend themselves against. It's just not going to work. So to illustrate how an attacker might actually do this, I do want to spend a minute here just going through a little bit of a flow diagram. So a lot of organizations try to tackle some of these threats by layering in multi-factor authentication. I want to illustrate how multi-factor authentication does not ultimately solve these problems and illustrate why we really need to move beyond that to something like FIDO and stop relying on passwords plus something else. So typically when a user is logging into an application, so it might be Office 365, which always uses Entra, they're going to get told to go get a token from Entra if they don't have a session already. So they have to go to Entra, request a token. Entra is going to respond with a challenge, basically saying, I need credentials from you. So the user might provide a password if we're using a traditional environment, and then we can evaluate their conditional access policies and say, I need you to do MFA. What we'll do is we will challenge that user for MFA in whatever way makes sense, given what they're registered for. So let's say it's an OTP code that we're texting them. We will send them that SMS code. It'll go through our telco, then to their telco, probably several telcos in the middle. You better hope that they haven't had their SIM card stolen. All that type of fun stuff applies here. And let's say that SMS successfully gets delivered to them. User will respond to that challenge. So they provided the password. They might provide that OTP that they were given over SMS. Entra gives them tokens. They send that token to the app, and the app provides the data. This is how it should work, and probably how it's working in most of your environments. But we do want to think about the bad case where the user does do something wrong. So obviously, end users can be tricked. And this is the scenario that Microsoft is super, super concerned about. And I'll talk about some of the numbers behind this that's driving our concern in a little bit. So the way this attack might start is the user receives an email with a malicious link. Almost everybody who does any type of end user support has probably dealt with end users who have clicked on things they should not have. I deal with it with my own family sometimes. It happens all over the place. They will get taken to the attacker's website, which in this case, let's say the attacker has used an attack suite that allows them to simulate the Microsoft Entra login page. It looks super real, but instead of O in the word Microsoft, it uses a 0. And the end user doesn't notice that the URL is off. They request that token to the attacker's website that they think is Entra. The attacker then turns around and sends that same request to Entra. From Entra's perspective, we just have an end user talking to us. We try to detect that this is happening. This is part of some of the risk analysis that we do, is we try to figure out when these types of things are going on. But it's not a perfect system. We're definitely playing whack-a-mole with the attackers when we try to detect this stuff. In the worst case scenario where they've tricked both the end user and they've tricked Microsoft, what will happen is we will respond with a challenge, just like we did before. That challenge goes back to the attacker, and the attacker shows it to the end user. Then, just as before, we will send the end user some sort of MFA challenge. So we'll send them another SMS with an OTP code in it. But then the really bad part happens, which is the user responds to that challenge, but on that login.microsoft with a 0 instead of an o.com website, instead of the real Entra web page. So they might give that attacker the user's password at this point. The user might also then give them that SMS OTP code. The attacker can then take that and send that to Entra. Entra does what it's supposed to do, which is it returns the token to whoever successfully provided us with proved credentials, which in this case is the attacker's website. Usually at this point, the attacker will show some sort of like authentication error to the end user and then redirect them off to the real Microsoft web page, so the end user doesn't necessarily know that something happened. Like at this point, the attacker has the token, they can impersonate the end user. So they present the token to the app, like Office 365. Office 365 is none the wiser, and it provides the data. So obviously this is very, very bad. We especially don't want this happening to our administrative users. So if you have not already gotten on the train of trying to prevent this type of attack with your admins, definitely get started. But ultimately, we need to try to prevent this type of attack for all of our end users. So the way that FIDO generally addresses this is we remove a bunch of these problems. So to go into a little bit of depth on that, there's really two protocols that make up FIDO or passkey authentication. There's WebAuthn, which is for the end user's client to talk to the web server, which in this case is Entra. And then there's CTAP, which is for whatever is holding the passkey to talk to the user's web client. So the web client will verify that the website is legitimate. So if it's login.microsoftonline.com with a 0 instead of an O, the client will detect that. Like it will basically see, this is not the website that I created this passkey for. So we're going to stop right here. This is part of the protocol. The authenticator talks directly to the agent, or so the user agent will basically talk directly to their authenticator. So if I have a YubiKey, for example, my end user must interface directly with the YubiKey, which must interface directly with the device. My YubiKey never actually talks directly to Entra. The credential must be present at the user agent, means we need to have like physical proximity, which helps deflect a lot of those like remote attacks where an attacker might like try to compromise a user through some sort of like proxied session. We always require that device-bound gesture, so the pin, the fingerprint, something like that in order to make this an MFA session. That private key is bound to that hardware, and all the responses are encrypted. And then all validated using that public key on the web server. So this is a very, very effective way to deflect these types of attacks. So ultimately, FIDO2 and credentials that work on these principles, whether it's a smart card, Windows Hello for Business, which is a type of FIDO2 platform authenticator, platform SSO, Passkeys and iCloud keychain, Google Password Manager, you name it. These are all secure by design to try to solve these problems. And so they also are designed to be user-friendly. And this is where they're a little bit different than smart cards, which are not always so user-friendly. You have to have things like smart card readers, or you have to have this big investment in separate hardware, things like that, to make smart cards really viable. But compared to passwords, these are much, much more user-friendly. Users don't need to remember passwords. They don't need to worry about rotating them on a regular basis. That private key is much stronger than what they would typically have. Now, they still have to remember the PIN if they're using a PIN, which is why like us and NIST and other bodies do recommend having simplified policies for PINs and things like no rotation and all that type of stuff. So if you don't believe me, go look at NIST's documentation on how to manage PINs. It is very different than managing passwords. It should be much easier, much harder to forget. No one-time passcodes, so you don't have to sit there waiting for those SMS codes to roll in, those emails to roll in. If you're on a plane and you don't have cell signal, you're not dead in the water because you can't get SMSs. And then the gestures are all simple. So especially if you're using biometrics like Face ID with a passkey, super, super easy and user-friendly. It's also very interoperable. So most of the major browsers support all this stuff now, like the Google Chromium project supports all this stuff, and therefore many other browsers just automatically inherit it. Other things like Safari also work with this. It works on all the major OS platforms, and it works for different form factors. So we have options for desktop, options for mobile, and I'll talk a little bit more about some of the deployment guidance around that in a bit. And it's standard. This is the other big thing. This would not work if this was like a Microsoft-only implementation. If we came out saying everybody's got to do this thing that Microsoft says they have to do, and it wasn't like an open standard, I don't think we would get any adoption. It's just not viable. So this is all based on an open standard that has industry buy-in. Like Microsoft's in the FIDO Alliance. There's many other big industry players in the FIDO Alliance, like Apple, Google, Cisco, you name it. There's tons of us in there. because it's understood that this is like an industry-wide problem that we need to solve. And I'm going to try to stop saying FIDO. I still do it reflexively out of habit, but really the way we should be referring to this stuff going forward is passkey. So if some of these concepts are new, or like FIDO is a new term for you, really what we're talking about is passkeys. Passkeys is kind of the consumer-friendly, industry-friendly term that we want to use going forward. So I'm going to try to use passkeys, but ultimately if I kind of flip-flop between these terms, just please understand that it's not because I'm confusing two different things. It's really just we are rebranding FIDO credential as passkeys, which is ultimately just a password replacement that is safer, easier, and faster to use. So I'm going to talk a little bit about passkeys in the enterprise and why we really, really want enterprises to start getting on this train and start adopting these. And one of those reasons is because we have seen uptake in the consumer world. Like we have PlayStation Network accounts, Xbox Live accounts, GitHub accounts. I did my taxes in the US this year with TurboTax, and I saw they added passkey support. There is a ton of consumer-facing web applications that support this stuff now. And so we're in this kind of weird spot where consumers are often using stronger credentials for their consumer websites and like their gaming systems and stuff like that than they're using at work. This is a problem. We probably do not want that situation to persist for too long. So we really need to get moving on some of this. But oftentimes the question I get from enterprises is, how do I actually do this in the enterprise? Like, what does this mean in an enterprise context? And so when I explain this to identity and security teams, the couple things that I mentioned about the why are really reiterations of some of what we've talked about here. Again, passwords are ultimately indefensible. I talk to a lot of security teams that will talk about password policy, or they'll want to talk to me about strategies for mitigating password spray and strategies for mitigating this password attack and that password attack. And at the end of the day, I tell them what I told you at the beginning, which is, I don't know if any of this really matters. We're kind of just taking a stab at solving some problem that might not be solvable, because these things can be created by the end user and therefore very weak. Even if you're using good password policies, like I would bet that there's users in your organization that are using summer 2025 ! As passwords right now. And if you tried to break into their account using that password, you would succeed. There's like a non-zero chance I could do that with someone's account in the room at this very moment, which is not good. Obviously, it can be phished. So even if the user is doing all the right stuff, it can be stolen. And then once stolen, it can be replayed. A lot of the customers I talk to are really fixated on MFA. But as we've talked about, MFA is hard to deploy at scale. It's slower. It makes the end user experience worse. End users generally hate it and try to resist it as much as they can. But we have options. There's new technology that allows for this cryptographically sound hardware-backed security, and this is where we need to go to. Microsoft does have some data that we use to actually back up some of our claims about the size of this threat. So we publish this report every year, which you can grab at this link in the lower left, aka.ms/MDDR. There's different versions of this report, but the one we released in 2021 had this really interesting stat that in successful breaches, there were something like 70% of them that involved phishing as some part of the attack chain. This kind of varied depending on the attack, but that's a huge percentage. So we really, really want to start trying to deflect from these types of attacks. Ultimately, I really like this picture because I think this kind of shows the scope of the problem. We have this bottom section of the pyramid, which is common attacks on our infrastructure. We have this kind of astounding number from our 2024 report that shows something about 7,000 password attacks per second on Microsoft services in 2024. That's a lot. Those are, by volume, like almost all deflectable, just using traditional MFA. So we're not super worried about these. Like, we are worried about them, but these are kind of a solvable problem. At scale, this is like mostly password spray and things like that, where attackers are just trying to guess users' passwords and hoping to get lucky. Like, they might try summer 2025 and see what happens. The part we're really worried about is the middle section of the pyramid, because this is where the successful attacks are coming from. Like the ones you see in the news are happening here at this middle section of the pyramid, which is attacks that are being successfully waged against organizations, even if they have multi-factor authentication enabled. The numbers here are way smaller. Like we're talking about tens of thousands of attacks per month. So the volume is much lower, but the success rate is tremendously higher. And the one that we're really worried about, especially because it's so scalable and easy to trick end users, is especially that adversary in the middle one, which I illustrated for you earlier. Traditional MFA, as I showed, is not going to help a ton with this. So we really need customers to get moving on the phishing-resistant part of their authentication strategy. And then ultimately, attackers will not stop just because we deploy phishing-resistant MFA. There is a top section of the pyramid, which is the type of thing that attackers are going to move on to next, which is things like session attacks and stuff like that, which I'm not going to spend too much time on. We did do some number crunching on the user experience side as well, which has some interesting findings. So this comes from the Microsoft consumer account ecosystem. So it's a little bit different than Entra Enterprise. This is like Xbox Live, Outlook.com. If you have like a Microsoft Family Plan for getting like personal versions of Office, this is where this number comes. But we've been pushing millions upon millions of users in that ecosystem to adopt Passkeys. It's really where we do a lot of our experimentation before we bring stuff to the enterprise. And what our numbers there show is that if users are using passwords, on average, it takes them about 24 seconds to sign in if they hit an Entra web page. So this is not too great, but it's not the worst number in the world either. What's really bad is when we layer in traditional forms of MFA. Users sitting around waiting for that SMS to roll in, or they're trying to remember what app has their OTP codes, or I talked to a customer where they have blue-collar workers who are going into like factory settings, and like they're always leaving their phone in the truck, and they have to run back outside and get the phone because it's got their OTP code on it or their SMS code on it. So the user experience here gets really degraded. When we switch these users over to Passkeys, we're authenticating them in about 8 seconds. So it's significantly faster than both passwords and especially passwords plus MFA. We also see much higher success rates, like it's north of 90%. I don't remember the exact number, but it's much higher success rates, much lower failure rates. And we're continuing to like invest and try to make this experience even better. Like we don't think we're done here. So we actually just wrapped up a rollout of an experiment that we did for the consumer accounts using something called Passkeys with autofill, where we can like proactively prompt the end user for their passkey rather than wait for them to present it. And this allows us to get the authentication down to about 2 seconds. So this essentially is just, we prompt the end user to do like a Face ID, they do the Face ID, and then they're off to the races. Like it should be that fast and easy. We want this on the enterprise side as well. The enterprise users are kind of suffering over in this bucket of like 69 seconds because they have traditional forms of MFA. We need to get them to the point where they're getting this beautiful 2-second authentication experience because they're using passkeys and phishing-resistant auth. All right, I'm going to spend a couple minutes on deployment approach. This is kind of generic. Again, this is actually based on Microsoft's own internal deployment with Microsoft Entra, and it goes for all of the operating systems that we use. Like I'm on a Mac that's managed by Microsoft. We obviously have Windows users, Android users, iOS users, but you could really make this kind of generic for any IDP if you really wanted to. But Microsoft, I think we had something called the Secure Future Initiative report card that we released in April. And I think in that we said we are at 94% phishing resistant for our employee tenant. We're higher than that now, but we're inching towards 100%. And this is the strategy we're using. So I'll hustle through some of this, and then we'll talk about some Apple-specific deployment recommendations. So if you don't remember anything else from this section, I would write down this link, and we will share slides later, so you can always get it from there, but it's aka.ms/passwordless guide. So this is how Microsoft did our own internal passwordless deployment, but turned into a customer-facing deployment guide. And what we found is that many customers put the cart before the horse. They say, I would like to go phishing resistant, and then they say, and I'm going to do it to this user, and this user, and this user. And those are 3 different types of users. Like you can have your admin, you have someone in your marketing department, you have a frontline worker, like that guy who works in the factory floor who leaves his phone in the truck. Those are 3 different types of users that we may need to make considerations for. So We always recommend doing a little bit of planning and investigation up front and understanding who are my user personas. Like if you're an educational institution using Macs, your students who are bouncing from lab PC to lab, or lab Mac to lab Mac to lab iPad, they're gonna have a very different set of needs and authentication experiences you need to drive than say your admin who has the same Mac laptop that they use every single day. Then you need to think about planning device readiness. This is actually pretty easy in the Apple ecosystem. In the Apple ecosystem, you should be on at least macOS Sonoma these days, I would say. Hopefully most people are on Sequoia. Obviously when Tahoe comes out, there's gonna be some new stuff there, so you may wanna think about how long is it gonna take you to get to Tahoe. On iOS, we do recommend at least iOS 18. There's some nice improvements there. iOS 17 does work in a pinch. Android's the messy one. Android support for some of this stuff is like a little bit variable. And this is where Microsoft really struggled in our deployment, was getting some of this done on Android. But Windows, macOS, iOS, fairly straightforward. Then you need to drive the registration. So anybody who's rolled out Platform SSO has probably seen this. Registration requires user action. This is not something you can just make the user do on behalf of the end user without their input. They have to set that PIN, or they have to register that biometric. They have to interface with the hardware in some way to get it to generate that public key, private key pair. And this is by design. Like, we really need to generate these things with the user's consent and knowledge. So if you're rolling this stuff out to your end users, you do want to think about, what's our registration campaign going to look like? How are we going to drive adoption? And then you really need to push it forward. Like, I talk to a lot of customers who will push the policy out through MDM or through Entra, and then they walk away and assume that all the users are registering. That is probably not realistic. Like, there are probably end users out there who you've pushed a PSSO policy to who have not touched that push notification that shows up every couple minutes in the upper right corner of their screen. They just refuse. So you need to track that. You need to understand, like, what does my data show about who has registered and who hasn't? Because ultimately, we need to get to the enforcement phase. And this is where we actually stop the attacks. We need to get to the point where you're using a tool like conditional access in the Entra world to say, no longer can you downgrade to a password and use this weaker credential, and therefore no longer can an attacker exploit the fact that you may have had a password or SMS or something like that. We're getting to the point where we are making the end user use these newer credentials and saying, no access to your email, your Teams, your Slack, your whatever, until you use this stronger credential. You need to do all these prerequisite steps before you get there. I can tell you from our own experience, if you just try to do enforcement without doing all the other stuff, you're gonna have a really bad time. This is a resume generating event here. So be very careful. Like, if we turn this on for our CEO and our board of directors without doing any due diligence, we'd probably deserve what's coming. And then don't forget that attackers don't stop there. Like, pushing out phishing resistance is not the end-all be-all. As much as I talk about it, you do want to think about, what are attackers going to move on to next? So you, as the device admins, have a really important role to play here, which is looking for that next set of attacks that are things like session attacks. Like, is an attacker trying to get malware onto a device so they can steal the tokens off of that device that were acquired using that passkey, and then, you know, taking those tokens and using them remotely. Like, that's the type of thing that attackers will move on to. And so as part of a defense in depth strategy, we do want to think about, how are we protecting these devices? So the flow that I would generally recommend, and something that we try to use internally at Microsoft and with some of our other customers, is one that kind of looks like this when it comes to the registration journey. Now, this will evolve a little bit over time as we add new features, support new things. But I'm going to actually demo what some of this looks like in a little bit. So generally, if you have a new user starting, like they're brand new, this is their first time, their first day at work, or it's a user who has never registered for MFA before, we can skip past the MFA registration step. And so if you live in the Microsoft Entra ecosystem, what we would recommend giving them is what's called a temporary access pass. This is a either one-time use or multi-use credential that is time-bound. Like, you essentially say, how many hours is this thing good for, and how many times can it be used? And the user can use that to go take another action, like setting up their first passkey. So what I'm going to demo in a little bit is the user taking a tap, using it to register for a passkey in the Microsoft Authenticator app, which is an option that we support today. We really want the user to start with something that has a portable quality to it, like a passkey in the Authenticator app, or a passkey on a physical FIDO2 security key like a YubiKey. That portable credential, like the passkey, can be used both on the iPhone or in a cross-device auth flow, which I'll show in a little bit. It's a very flexible credential, so usually this is where we want them to start. Then we want the user to move on to setting up a locally available phishing-resistant credential on each device that they regularly use for work. So in the case of say like an information worker who works on a Mac, you would have them take that passkey that they set up with the tap and now use that passkey to bootstrap platform SSO secure enclave key, which is what I'm going to show. Same thing on Windows. You could set up Windows Hello for Business using that passkey. This preserves the good end user experience. So we want to make sure that the end user has something that's locally available on each managed, regularly used device in order to optimize and provide them with the best user experience possible. So you may need to change this flow depending on your needs, depending on the user personas we're talking about. Like for students, you might do something different. For teachers, you might do something slightly different. But this is the type of journey you need to design in order to make this all work. Again, when it comes to doing the rollout, we recommend kind of bifurcating by OS. So if you're working with iOS, like do your data analysis up front. Like go look in your MDM and figure out how many devices do I have that are running sufficiently up-to-date versions of iOS? How many devices do I have that are out of date? Do I have macOS 12 in the environment that I need to go fix up? You want to find all that stuff ahead of time, because if you start pushing this stuff out and the user's on some old OS, they're not going to have a great time. And as you push these things out, if you have a really high user volume like we do, you do need to think about things like working with your help desk to make sure you're not swamping them. Like if we turned on enforcement for 20,000 Android users on the same day, our help desk would have a really bad time. So we worked really closely with them to kind of coordinate how we did this. But ultimately, the goal is to get to this point where you're using a conditional access policy that basically looks like this. A conditional access policy in Entra that says you have to use Windows Hello for Business, SSO secure enclave key, a pass key, or a FIDO2 key, or in a pinch, a multi-factor certificate, which is typically a smart card. And at this point, if you have created this conditional access policy and applied it to most of your applications, attackers can no longer wage a downgrade attack on you. All right, so let's talk about some more specifics for the Apple environment. Like, what do I do with my iPhone users? What do I do with my Android or my Mac OS users? I'm not going to talk about Android. All right. So I have 3 top recommendations for anybody in an Apple-centric environment that I'd really like them to do if they're using Entra as their IDP. So the first is register your new users for a passkey using a TAP, or a temporary access pass. So what this looks like is, again, you're going to create a TAP. This can be used to bootstrap a more durable credential. TAPs are time-bound because it is ultimately just like a string that you're going to enter, sort of like looks kind of like a password. It's not in the way that it's managed, but ultimately it's something that's stealable. So we want it to be very short-lived, so that the window to steal it is very small, and we want the user to have something more durable and long-lasting, like that passkey on their phone. So use this instead of what you might be doing today, like giving users temporary passwords and then having them change or reset their password on their first day. The time to move beyond passwords is very close, so we want to think about evolving those processes. I think I'm wandering too far away. All right, so you're going to typically use that tap to set up something like the Authenticator app or a FIDO2 security key. But I do want to make one call out for some more complex scenarios around corporate-owned devices. So if you have corporate-owned iPhones and you're going through automated device enrollment, there's a need often to authenticate with Entra during the automated device enrollment phase, and then subsequently install Authenticator, and then make the user authenticate again inside the Authenticator app. So it's kind of a chicken or the egg thing. So if you have this type of setup with corporate-owned devices rather than BYOD, you probably want to consider using what we call multi-use taps. So a tap that can be used more than once. So you're going to use it at least twice. Once to authenticate to kick off automated device enrollment, and then a second time to go into the Authenticator app and complete what I'm about to show on the right-hand side here. If you have BYOD, only thing you really need to do is get the user to install Authenticator, and the tap only really needs to get used one time. So what this is going to look like is the user will open Authenticator, say, I would like to add my account, so they click Add Work or School Account, and say Sign In. So they'll type in their username, hit Next, they'll provide the tap, which we don't show here because I don't really want you to have any taps that I issued, and then they will be provided with a set of instructions that they need to complete in order to get this all set up. There's a requirement for them to at least have a passcode, if not biometrics, set up on the device. So we check and see, do they have a passcode? And if not, we make them create one. And then they have to go into the settings for the Passwords app on their phone and turn on Authenticator as a passkey provider. And so this allows the phone to interface with Authenticator to actually do authentication using this passkey that we created. And then continue. The tap is used to acquire a token from Entra, complete the passkey registration, and we're done. So that is it. Like, it's super easy to get a tap and then, or to have an admin issue the user a tap and then have the end user use the tap to go register for something like a passkey. There's other ways taps can be used, but this is a really strong option that we'd like customers to consider. One thing I'll note with Passkeys and Authenticator app is they don't sync anywhere. They only live on that particular phone. So if the user loses that phone, they break the phone, they just get a new phone because it's September and that's when you get new phones, then they will have to go through some sort of process like this again, either with a tap or with another phone that's got a passkey on it. These don't sync in Authenticator app. The second thing we want the user to do is now use that passkey to set up their Mac for Platform SSO Secure Enclave Key. So again, a couple things to think about here. So the first is I highly recommend integrating Apple Business Manager with your IDP, which in this case would be Entra. Again, you could do this with other IDPs, other implementations, but you're in the room, so I'm going to talk about Entra. But you really want to integrate ABM. There's been a lot of talk at this conference about managed Apple accounts and how to get moved over to them. Start that work sooner rather than later. It's going to pay dividends down the road. So you're going to, in that automated device enrollment flow, you're going to use the passkey to kick that off. The user does not need to use a password. They don't need to use any sort of stealable, phishable credential. We can do this all using passkeys. When they do get to the local account setup process, which still exists, like we still have the file vault screen, we still have this need for setting a password that is local to the hardware of the device, or what I sometimes refer to as a PIN. We're going to have them set that up in this flow still. But then they're also going to use the passkey to bootstrap Platform SSO Secure Enclave Key once they hit the desktop. So at no point are they going to use a passkey that goes, or a password that goes over the network and is validated by Entra and is stealable and phishable. So what this is going to look like is I begin using Setup Assistant, jump through a couple screens here, and click Enroll to get my remote management. I'm using ABM, so I am directed to authenticate with my federation provider, which is Entra. And in this case, the user is going to use their passkey. So they go to the face fingerprint pin or security key option, say they would like to use an iPhone, iPad, or Android device to authenticate, and they get a QR code. They scan that QR code with that iPhone that they already have the passkey on. They complete a Face ID on the iPhone. The two devices use Bluetooth Low Energy to establish that they're physically close to each other, but Entra brokers the rest of the authentication. This is a fully phishing-resistant, FIDO-compliant authentication. At that point, the user is authenticated, they've gotten their tokens from Entra, and the rest of this process can continue. So at this point, it's now enrolling into Intune, which is the MDM I used for the purposes of this demo. So it's pulling down policies, all the standard type of enrollment stuff we would expect. There's really no special sauce at this point. So this process will continue for a little bit. I forget exactly how long when I practice this.
This is assuming that you are supporting BYOD for mobile devices, right? Because what if you don't do that?
So the question was, this is assuming you are supporting BYOD for mobile devices. What if you don't do that? So we're talking about the iPhone as the mobile device. So the passkey flow is really independent of how the phone is managed. Like creating a passkey on the iPhone can be done regardless of if it's BYOD or a corporate-owned device. If it's a corporate-owned device, you do need to think about that multi-use tap option I talked about. let's put a pin in that one, and we will, let's take that question at the end. All right, so here I'm creating the pin. I know it says password on the screen. I would love to see that change or be a customizable string. But anyway, it says password today. It's a local device-bound secret, though. It's not something that's transmitted to Entra or any other directory, and therefore is phishable. And at this point, I just need to run through the rest of Setup Assistant. And this is all happening on Sequoia, so the current publicly available version of macOS. So the last thing I need to do is finish Platform SSO setup. So I'm a good user, so I don't ignore that notification. I click on it. It launches Platform SSO. I provide that local PIN, and I'm once again asked to authenticate with Entra to bootstrap SSO. I am again going to use that durable, reusable passkey that I have on the mobile device, which in this case, again, is going to invoke the QR code scanning because I don't have any credential locally available on the Mac yet. So I'm authenticating to Entra with the credential I have on the phone, which involves just scanning and Face ID. The devices talk to each other again. They both also talk to Entra. And at this point, I am strongly authenticated, and Platform SSO setup can continue and complete properly, which involves doing an Entra ID join and a couple other steps. The last part of this process, once the device registration completes, is that secure enclave key that the user is going to use to authenticate is created, and then they're instructed to go and turn on Company Portal as a passkey provider. It's mostly not going to get used as a passkey provider, but in a pinch, if something goes wrong or the user needs to re-authenticate because you set up conditional access in a certain way, it's very helpful to have that toggle enabled. It just lets them use Touch ID to re-authenticate, like in Safari or Edge or other desktop apps. Just to illustrate that at this point, SSO is bootstrapped, I go to the portal.office.com and I'm taken right in. So that is the end-to-end flow that we would really like to see customers kind of striving for going forward, is let's bootstrap the end user on their mobile device, get them something really strong like a passkey. In a little bit in the Q&A, we can talk about what to do if they don't have mobile devices, which someone wanted to ask. And then let's get them bootstrapped for a phishing-resistant cred directly on the Mac as well. Now they can use Platform SSO on the Mac to have a nice, smooth, very strong user experience on the Mac, and they can use that passkey on the mobile device to have the same thing there. So just to reiterate, there's 3 options here. I don't want to hear about anybody doing password, so none of that. If you do smart card, that's okay, I can live with it. You probably have your reasons, but ultimately where we think most customers need to be going towards is passkeys and secure enclave key auth. All right, one last thing I'm going to add on recommendations for an Apple environment is you should be configuring SSO for both the cloud and on-prem. So this is something we added later last year to Platform SSO, is in addition to the standard stuff, which is doing SSO for cloud resources, we can also handle SSO through Entra for your on-prem Active Directory resources. I would highly recommend moving in this direction and starting to deprecate the use of alternative tools for doing Kerberos. There's lots of stuff we've seen customers use, like third-party tooling, native Apple capabilities, old Nomad deployments, all sorts of stuff. Generally, we think you should start thinking about moving that to Platform SSO, so you just get SSO to both cloud and on-prem in one fell swoop with just a single tool. There's a bunch of prerequisites that are required to make this all work. You may need to work with your directory team, your identity team. Check out the link, aka.ms/psso Kerberos, to get more details on all the implementation details for that. But I find that this is super helpful for simplifying your deployment. All right, a couple things on what's next, and then I will take some questions. So there's a couple things missing in this story. The obvious one that's been talked about a bunch is, why do I have to do that second authentication when the user hits the desktop? It'd be really nice if I just did one authentication during Setup Assistant and the user was off to the races. So Apple announced support for this. We are looking at it on the Microsoft side. I can't share any dates today, but we know that this is like a top requested feature. So we're going to very actively look at what it's going to take for us to properly support this. So give us a little bit of time and we will try to sort this one out. The Authenticator app was very prominently featured here, and I do talk to a lot of customers, like one who's sitting up front here, who don't necessarily want to rely on the Authenticator app or a FIDO2 security key. Like you might want passkeys in other apps, like I use 1Password for my personal stuff. It might be useful to put passkeys in 1Password or iCloud Keychain. We have publicly committed to supporting third-party passkey managers, synced passkeys, things like that. Again, I can't share dates, but I would like to reiterate, this is something that we are going to work on. One thing that I have no plans for, because I need Apple's help, is I would really love to see a feature where if we give the user a YubiKey rather than an iPhone, that they could sign into that device with the YubiKey without needing to put a smart card certificate on it. I was really hoping for that one this year. It didn't show up, so I'm going to ask for it again, and hopefully we'll get it next year. Some sort of tooling for making it easier to issue taps would be really nice. What we hear from a lot of customers is they want to have identity verification, this kind of end user self-service where you do some sort of like document check. You can get the end user to like show a driver's license, do a liveness check, all that type of fun stuff, and then issue them the tap, and the admin doesn't have to do that work. We have some capabilities in Entra today. It's not really widely deployed. So it's something that I think we need to mature both our deployment guidance and get more customers to adopt and mature the product. So something to look forward to. And then the final one is general availability. I am, again, not going to share dates, not because I don't know the proposed date, but because the moment I say it out loud, we will miss it. But we are very close. I know that this is a blocker for a number of customers that Microsoft's support for Platform SSO is still in public preview. I promise we're very close. We're working hard on this. We know we need to get it to general availability. We have like one more issue we're going to solve, and then we're going to be ready to go. So to wrap up, because I know I'm a little over time and I want to get to Q&A, a couple go-dos. First, turn on the passkey policy in your Entra ID tenant. It is off by default. So if nobody has taken an action to turn it on, to start allowing end users to use passkeys, either in a YubiKey or an Authenticator app or some other option, go enable it. Start kicking the tires on these things. Someday we will get to the point where we turn it on for you, but we're not there yet. Read the deployment guide. So I cannot reiterate enough, this thing is super useful. Begin using some of these phishing-resistant methods to at least start to get some understanding about how they work, what the user experiences look like, and then start forcing yourself to use them. So even if you're not ready to roll out org-wide, look at what enforcement looks like. So for your IT staff, if you roll out a requirement to use PSSO secure enclave key, start preventing them from using passwords, get those experiences under your belt. Design an end-to-end strategy for user onboarding and recovery. This is a part that a lot of customers miss. Like, how are you going to give the user that tap? What is their user journey going to look like from tap to iPhone to Mac or some other journey that you design? Deploy passkeys on iOS. This is the best phishing-resistant option on iOS typically. Deploy secure enclave key on macOS. This is the best phishing-resistant option on a managed Mac typically. Be data-driven, especially for that enforcement step. I mentioned that it is a very risky step professionally. If you don't take a data-driven approach, you want to make sure you're not going to break your whole environment, impact your business's ability to do business. And then check out some of the other sessions. One of these was this morning already, so check out the recording. My colleague Chris from the Intune team is going to talk about some Intune specific stuff tomorrow afternoon. Matt Vlasik from Jamf did a great session on the state of identity on Apple devices that I really enjoyed. I highly recommend looking at that one too. All right, I will take questions. We do have the cube. I know the gentleman here had a question, so maybe we'll pass this back to the man in blue.
So what does that workflow look like for people who don't have mobile devices?
What does it look like for people who don't have mobile devices? Do they have a Mac? And that's it. I would just cut the iPhone step out and use the tap to bootstrap the Mac if they have no phone.
In our org, I've been testing this out, but they're really persistent on using passwords because that's what Microsoft has told them to do and to rotate. every 90 days. It's not a matter of can we action it. It's a matter of convincing others higher up in our GSO and SOC to be able to use passkeys in Secure Enclave.
Yeah, and I don't know if the catch box is working, but I'll
Probably
repeat
not.
the question. So the challenge that was expressed is it's sometimes hard to convince decision makers to do this, especially when someone at Microsoft is telling you do password stuff with password rotation. So the first thing is I would say those people at Microsoft are incorrect and a little out of date. So you can always send them our way and we will try to educate them. So you can always email me and point it out. We'll try to help. When I talk to decision makers, often I find that the easiest thing to kind of lean on to convince them that this is the right direction to go is to point at NIST's guidance, because it's a little bit independent from Microsoft and a lot of people trust it, like globally. NIST is saying a lot of the same stuff that we're saying about like moving towards phishing-resistant authentication, simplified PINs, simplified rotation, getting away from passwords, password rotation, all that stuff. So there are documents from NIST that kind of say the same stuff. We have recordings of us reiterating it if that's helpful. But ultimately, if you need to hear it from Microsoft, I can come talk to your customer. Someone from my team can come talk to you, or we can try to educate your Microsoft account team on the new ways. Cool. Next guy back.
Right. Let's see if this is done right. Hello? Can you hear me?
Okay.
Okay.
It's too quiet for me.
Guys, speak up. Two questions for public student labs. How does this look? How does this work? And when you're doing remote work and you're on a remote system and it asks for authentication, how does that work?
So the first question was around student labs. Secure Enclave key might not make sense for a student lab. It's one of those scenarios where I think the story may break down, is if you have these like shared devices that different people pop in and out on. I think some of the features Apple announced for Tahoe really help solve these problems in a more elegant way than using passwords. So for today, if I have an education customer who needs to do something like this in a lab environment, I would probably tell them to do password sync as much as I don't like it. And then in the future, start to switch to stuff like Apple's unauthenticated guest mode option or the tap to log in with iPhone option that they're talking about. But it's early days for those. So, and then your second part of your question was around
Doing remote work, like if you're logged in to a remote system, how does that work?
So generally, so the question was around logging into a remote system. Generally, this is a problem we can solve on Windows, but we don't have a good solution on macOS today. So one of the things that makes these credentials more secure is preventing their remote exploitation. And so on Macs, you can still use this secure enclave backed key if you remote into the device. So the user doesn't have to have physical proof of presence. There's two ways to prevent that. One is very easy, which is just prevent remote access to your Macs, and that using like MDM. It's kind of like taking a hammer approach, so that may not be a great option, but it works. The other option is we did add a capability that Apple introduced and we added support for a few months back to force the use of the biometric every time the credential is used. So even if the user signs into the Mac with like the local PIN or password, we can still trigger the use of the biometric. And that will prevent remote use of the credential, which is good for security. You want to be a little careful with that because if you have a Mac that doesn't support biometrics, the user's dead in the water. But in general, they should not be using these credentials over remote connections, at least today. You want to basically try to prevent it. On the Windows side, we have something called WebAuthn redirection, where we can take like a FIDO challenge and redirect it to whatever device is physically sitting in front of the end user. This doesn't exist for VNC today. So either block remote connections or think about requiring the use of the biometric so that the user can't be exploited if you have to leave remote access available.
Well, say you're over a VPN to a server and it's a Windows server that you're managing.
So if you're logging into a Windows server, so the Windows server needs to trust something. So if the Windows server trusts tokens from Entra, you can use these credentials to initiate that RDP connection because we can acquire a token from Entra present it to the Windows server, and then sign into it using Entra, as long as the server is hybrid joined to Entra in some way. Most Windows servers aren't. Like most Windows servers are only joined to an on-prem Active Directory. They have no relationship with Entra. Then you're going back to providing certificates for smart card authentication as your phishing-resistant method, because that's what on-prem only domain-joined Windows devices trust. There's a gentleman in the back.
Is there? Oh. Yeah, so we have a, well, can you hear me?
Yep.
We've set this up for testing. We have a battleship-sized company, right? So there's a 3-year plan to go passwordless. It's not going to happen soon. But we can get it working with Secure Enclave for a while. We also, for some things, use Azure MFA, but you only do more of that, only allowing Azure MFA to work. But we also use a third-party MFA for things that Microsoft will allow you to use a third-party MFA for. So we have like a mixed setup where some things are Azure MFA, some things are another MFA. And we also have session timeouts on trusting the systems. So every couple of weeks, you have to basically re-MFA to get the system to work, or you lose access to everything. And in our testing, we can get it working for a couple of weeks, and then it kind of breaks down without some juggling to get it to work again. Is there any chance you think we can get this to move forward, or? And then the other question is around, since we're going to have passwords for another 3 years, give or take, and how do we, if we move away from Kerberos extension, right, or an alternative similar to that, how do you guys recommend dealing with that?
Sure. So on the first question, sorry, I'm now thinking about the Kerberos scenario. The first scenario is about, sorry, just give me a quick reminder on the first scenario.
So
Mixed
first scenario, we can get this working.
Yes, yes.
We have passwords. We're not getting rid of them soon. I'd like to, but it's not a me decision, and it's just too big of a company to get rid of them soon, right?
So you're finding that your SSO stuff is breaking every couple weeks when your policy comes in that basically nukes the session.
Yeah, basically.
So typically, I assume you're doing this using what's called sign-in frequency policies
I
and
believe so.
conditional access.
Yeah.
Yeah, so the top recommendation I would make is stop doing that.
Well, we're just starting, so I may have to have an offline discussion with somebody from Microsoft about that.
To elaborate on the sign-in frequency thing, like using conditional access is very good. Sign-in frequency policies, if you're not familiar with them, are a way to basically limit how long a user session can last before they have to interactively re-authenticate. This is actively user hostile in some ways. Like you're essentially getting in the user's face and saying, I'm going to blow up your workflow because some arbitrary clock has reached midnight. I understand that there are valid scenarios for wanting to do that. I would argue that a corporate managed device that's in a healthy state is not one of those. So generally what we would recommend for sign-in frequency is use it sparingly. Like unmanaged devices, great scenario. Like if I need to check my webmail on my parents' PC when I'm at their house, great scenario. If it's an unhealthy device, like the MDM is telling us this device is in a bad state, sure, get in the user's face all you want because the device is in a bad state. But if it's a healthy device that's well managed, everything seems to be going well, getting in the user's face and basically ruining their day because some arbitrary clock reached midnight is generally not what we would want to see organizations do. So our top recommendation there is stop using sign-in frequency on like corporate managed devices, which I know your device has to be if you're using platform SSO. So that's kind of the top recommendation. We haven't come out publicly and said that too much yet, but we're going to. We're going to actually start putting this in some of our passwordless docs, like that passwordless guide. We're going to do a revamp this fall that basically says stop doing sign-in frequency.
All right. Yeah, it's piloted on all IT people in the firm right now. So we're going to start, so we may need to connect with Microsoft about, yeah. that.
And I have 7 seconds left, so I'm not going to be able to get to the second part, but if you want to come up and
Alright.
chat, we can. Thank you, everyone. Appreciate the time.